Good afternoon. Can everybody raise their hand if they can hear me? Good? Awesome. How many of you are running Java applications that were written from before you joined your current company? How many of those applications were written more than 10 years ago? Wow. How many of those applications were written more than 20 years ago? Okay, still about 25%. That was before cloud computing. Now, you could choose to maintain the status quo, but hopefully you're here today because you want to modernize your application. In fact, for many of our customers, the question is no longer whether to modernize, it's how to do so and to do it safely, securely, and efficiently. That's exactly what we're going to explore today. My name is Ben Coburn. I'm a principal go-to-market specialist with AWS in our next-gen developer experience organization.
Hey, I'm Venu Vasudevan. I'm a senior specialist solutions architect from the same next-gen developer experience team.
Hey, myself Vijay Golla. I'm director application development at ADP.
Thank you.
Thank you.
Thank you.
To start off, we're going to talk through some common issues with modernization and how we solve them. Then we'll hear a real-world example from Vijay about his experience at ADP modernizing their Java applications. Finally, we'll outline where past approaches have fallen short and introduce you to the latest offerings from AWS that address these challenges. So first, let's discuss challenges with application maintenance and upgrades. Now, I know Halloween was about a month ago, but when you take on a modernization project, you open the door to a few modernization monsters. So you may be familiar with a few of them. First up, we have the documentation dragon. When you're upgrading your application to a newer version of Java, you're changing a large amount of code, and this in turn requires extensive updates to your existing documentation. And that can be a full-time job. One other side of the documentation dragon is that your old legacy Java app may not have great documentation, and that alone can be a non-starter. These legacy apps often contain custom caching mechanisms or connection pooling, and without high-quality documentation, it can take days to understand the ins and outs of the module before you effectively upgrade it. Next, you may be familiar with the testing troll. Newer versions of Java can't always be tested in the same way as older versions of Java. So this pesky little guy is going to break your unit tests. An old school example that some of you may be familiar with is tests that rely on internal Sun classes that were removed after Java 9, or an outdated testing framework like PowerMock that isn't compatible with newer Java versions. Let's move on. The module monster. As you know, your enterprise application isn't just one thing. It's a complex ecosystem of interconnected modules, each with interconnected services, libraries, and various components. So when one part of your application gets upgraded, it can create a negative domino effect, which can go from your core service module, for example, and then may in turn impact your logging framework, which may in turn impact your monitoring modules, and ultimately your reporting services. Got a few more of these guys. Let me introduce you to the dreaded version vampire. Upgrading from one version to another version of Java introduces breaking changes because things are just done differently in later versions. A classic example is the removal of Jaxby from Java 11, which breaks many applications using XML processing. All of these illustrations were created by Kiro CLI, by the way. The dependency dinosaur. Your app may have tens or hundreds of third-party dependencies, whether software packages or libraries, and you need to find versions that are compatible with newer Java versions. Most commonly, these types of dependencies are for logging, testing, parsing, web support, or security. And lastly, the scariest of all is the time-sucking tarantula. Given the previous 5 monsters, this process just takes time, and it's no wonder that it ends up in the backlog and adding to tech debt in our organizations. It can take months or years to upgrade a production application. So it's no wonder that these projects go unaddressed. The modernization monsters, as I like to call them, are daunting no matter how many times you've encountered them. And even the most seasoned developers would rather apply their creativity to a new project or a new piece of innovation. So, how do we solve these challenges with AI? If you've been using AI over the last couple of years, you may be familiar with some of these techniques. We can use an AI agent to modernize your application, taking care of all the complexities and monsters that we just discussed. At AWS, we originally released this capability inside of Amazon Q Developer. And a bit later, we'll talk about how this capability is evolving today. When you call the Java transformation agent from inside of your IDE, it's going to do a few things. It will verify your project with a local build. It'll analyze that project for things like JDK runtimes, dependencies such as Spring Boot, and find replacements to deprecated libraries like Sun. Third, it will create a custom transformation plan for you to review before it does anything. Now, during transformation, code generation happens on the server side in the cloud, while the agent will perform verification builds with unit tests in your local environment. After transforming your code, you'll see a file diff to review all changes before accepting them. For larger projects, there are strategies you can use to chunk your work into multiple patches. For example, starting with one patch that just is for the minimal upgrades of the most popular libraries. In other words, some of the aspects that are least likely to break your application and are low-hanging fruit. The key concept that I want to highlight here is that we're not just generating new code and stopping there. We're giving this agent the ability to implement and test and only move on once the builds are successful. And this happens in many cycles through the transformation. Now I want to hand it over to Vijay from ADP to talk a little bit about how they went through this process in his organization and for their Java applications.
Thank you, Ben. Hello again. Good afternoon. Again, myself, Vijay Golla, Director at ADP for Application Development. How many of you are aware of ADP? You can raise your hands. And how many of you are getting your paychecks, W-2s through ADP? That's a good number. Thank you. So I have 17 years of experience in developing Java applications for enterprise solutions. So I have seen myself from like Java 4, the versions evolution, all the way now it's like 23. So whenever we go from one version to other version, we all know like whatever Ben spoke about the monsters, it all runs around our mind, right? So how do we overcome that with the Gen AI? So ADP worldwide. So we all know, right, we are global leader in payroll and HR services with an experience of 75 years expertise. And we are serving like 1.1 million customers and then giving our paychecks. 42 million workers are getting paychecks through ADP. It's a big number. So we have like taking care of the workers from hiring to the retirement, all the services end to end. So again, I'm part of global payroll. So my team is responsible for delivering the global payroll, where we deal with the multinational companies, which are part of Fortune 500. Again, like together, all we are serving like 2,800 clients, and then we are delivering the paychecks, tax documents, everything, and we have 6 million users accessing our global payroll portal. We are part of global payroll. We are serving across 140 countries. It's huge. Again, these are just not the numbers. They are the real people we are serving. So part of the global payroll, two main things which we consider is like compliance and security. So these are like non-negotiable for us. So we always ensure like our software or like our compliance is up to date. Is it on? So yeah, compliance and security. So how do we address this in the software development? So part of global payroll, again, what are the challenges we have? We have like a Java services in our portal. We want to address the challenges. Let's see what are these challenges. Java applications modernization has like Java 8.11. We all know it is end of life is coming, and support is getting ended. We want to ensure like the support is there. We don't want to end up no support from the vendors, right? So compliance requirements, like I said, it's not negotiable for us. Security, vulnerabilities, if there is no support from the vendors, we end up dealing with the security vulnerabilities. Resiliency improvements, whenever you're not upgrading your Java, we are losing a lot of patches, upgrades, improvements. We won't get those, right? Performance, latest Java is giving a lot of performance improvements for us. If we don't upgrade, we lose them. So we have to upgrade those. So again, like going back, sorry. So when we want to address these challenges, right, if we do it manually, it will take huge amount of time. How do we accelerate this in this era of Gen AI? So we partnered with AWS team. So how do we address this problem for us? So we have taken small application. We have done a POC using transform agent with the Java. So we were able to transform the POC seamless. We were able to understand what it is doing. So we are confident, like, okay, we can go with the pilot program. So our global payroll portal was the pilot program where we are running like 40 plus Java services. So part of the transformation, we learned a lot of things. So once we do the transformation, so how it works is like you're in your IDE, you go just give a prompt / transformation. It is amazing. It does everything for you. So it name it like it identifies what Java you're running. It identifies the dependency stack. What are the third-party dependencies you have? It is going to resolve all of them. So what it does is like it does the iterative process to update those dependencies and fixing the builds, removing the deprecated code. So all those things are and it documents everything, what it is doing. So that's all we were looking at the monsters, right? So we are solving all those things. A second key outcome we have seen is like developers' productivity. If you are doing these things manually, for example, if you are taking a complex application, it might take days. Let's take like 3 to 4 days. So using the transformation agent, we were able to transform this application in 3 to 4 hours. Now we are speaking days into hours. So this is one application. We have exercised as a pilot, 40 services. Our experience is like it is saving 60% of the time. So when you save 60% of the time from your developers, they can use that time elsewhere for developing new feature for your customers or innovation. Again, it's improved the application's resiliency and the reliability because latest Java versions are providing out of the box. We can leverage those. Again, it improved the performance as well. We know like latest Java has a lot of performance improvements. So part of the migration, we were able to see like a lot of performance is improved. Now, okay, we transform the code. Okay, good. How do we test it? What happens to my unit test cases, which are existing ones? So part of the Java transformation, it takes care of your unit test cases as well. There is an option to choose. You can run your unit test cases post-migration. It does run. It will fix automatically. It will give a detailed report for us. Now, unit test is good. However, the functional testing. We want to ensure before and after our application is working fine, right? So we were able to use dev agents to develop automation scripts and update our existing automation scripts. So one GenAI suite is giving for you to transform, test it, deliver it. Again, simple metrics. Again, after our experience, we were able to save 60% of the time. It is 60% faster. Like I said, 40 plus services we were able to migrate within less time. So it used to take months, it's weeks. Then total number of lines of code which we processed for this 40 services is like 600,000 lines of code. And again, like when we did that, whenever you're upgrading your dependencies, the third-party libraries also have end of life, right? That is vulnerable. If you go and check your CVEs, a lot of CVEs are reported in your report. Now, before and after when we compared, 85% of the CVEs are down, high critical. So that is win and win. Now, again, like whenever you do this transformation, does it do everything for you? We have a variety of applications, Tomcat and Spring Boot. So in Spring Boot scenarios, most of the time it's seamless. When you have a complex Tomcat applications, monolithic applications, we have seen it is 85% accurate. It is doing the job. There is human in the loop. We need to fix 15 to 20% of the job to make it successful. That's what I said, like 85%. Now, we did a pilot, good. How do we scale it to the organization level? So at ADP, we have a Center of Excellence team. We were able to demonstrate these experiences within the BUs. We were able to share our knowledge. So now we rolled out to many BUs, how do we advance our Java applications to the latest versions. So we were able to migrate hundreds of applications now after the POC and pilot program. Second thing is like developers, right? We are doing good. how do we empower your organization with all these tools? We need to give access to the developers. If we don't give access to the developers with all these amazing tools, we will not see the outcome, right? We were able to give access to our developers to use all these Gen AI tools. So we were able to achieve our goals. Quality gates, like I said, we were able to see unit test cases, and we were able to see automation test scripts are taken care. We were ensuring like all the code, whatever is transformed by GenAI, we were able to review it, we were able to test it, and we were able to deliver it. Change management, again, like I said, we have a strategic approach. How do we bring from one BU to other BU? So that was good. Again, yeah, I think that's pretty much it from our side. Maybe Venu can take it over.
Thank you so much, Vijay. So that is really impressive metrics out there, like 60% faster upgrades. And thank you for sharing your customer success story here. Now, what's the future? Where do we go from here, right? This is great, right? Where do we go next? What is the future that we are evolving this Java transformation agent into, right? So I want to quickly talk about the current Java transformation agent that we have. How does it work, right? Like Ben mentioned, it's an IDE-based experience where it takes your Java code as a project and build and test in the source version, make sure it all works. Then it applies static recipes, hey, Spring Boot upgrades or JUnit upgrades, etc. And then build and test it in the target version, which could be 17 or 21. And if there are any issues, it goes to GenAI, large language models, to make sure that it fixes that and give you the completed upgraded source code, right? That's exactly the source workflow that is currently part of Java Transformation Agent. Now, why do we need something better, right? So customers often told us when we talk to customers, this is great, it's doing the job, what we wanted, but our situation is little unique, right? Like, one of the main thing that customers told us was, beyond runtime upgrades, can it also do deployment upgrades? Like, hey, I have a Terraform, I have a SQL, embedded SQL. Can it also upgrade that, right? And the other thing is, I have JSPs, UI layers. Can it also upgrade the UI layer to a modern layer, right? And from a flexibility standpoint, this is great from an IDE standpoint, but my developer has to load the project in the IDE and do the transformation. Can I integrate this with my CI/CD pipelines, right? Or can I give my own prompts because I have something unique? I have an internal library that I want to upgrade as with the Java application. Can I do that? As well as I have very specific libraries, like I want to upgrade only Spring Boot in my application. Can I very targeted upgrades can be done or not, right? And the other thing we always hear from the customer is, can it support other build systems, right? Like Gradle and Bazel, all those things as well, right? Another thing I always hear from the customer is, upgrades are great, it was able to upgrade the version, but can it also modernize? Can it use Java 21 latest features like streams, records, right? And another thing is at-scale upgrades. Again, I have 1,000 applications in Java 1.8. Can I upgrade it all together, right? Those are common questions I always get asked from the customers, right? So the current Java transformation, again, it can address some of them, but not all of them, right? That's why we wanted to do something better, okay? So introducing AWS Transform Custom. So this was released this week, right? Our CEO, Matt Garman, announced it yesterday on the keynote as well, right? To crush the tech debt with AWS Transform Custom. Okay, so what does it do, right? So again, we just took a step back from the current Java modernization agent and thought, instead of creating agents for specific use cases, agent for JSPs, agent for Terraform, etc., we took a step back and we thought, why don't we give an agent that customers can use and create their own transformations, right? Giving their own requirements, giving their own organization-specific context, right? So what organization need is an intelligent AI agent that can learn from your organization-specific context, your own requirements, and create a scalable transformation that you can apply for not only one repository, but also integrate with your existing systems and apply at scale. That's what organizations need, right? And so this agent, the AWS Transform Custom, it's a command line interface-based autonomous agent that will do the exact thing that I described, right? It basically supports any code patterns, so which means not only Java, it could do .NET to Java as well, like language to language conversions, and it supports various scenarios, right? Hey, you want to target specific frameworks. I want to just upgrade Spring Boot, or I want to just upgrade Hibernate. It could do that. Or again, language to language conversion. I want to go from Python to Java, or Java to something else, or Java version upgrade. It could do that, right? And also architectural changes. Hey, I have something in x86. I want to migrate my Java application from x86 to Graviton. Yes, that is also supported, right? So it's basically breaking the barriers of all the languages, frameworks. We're giving you an agent where you can customize it and do it on your own, right? Another main part is the continual learning aspect, right? Basically, it can learn from your feedback. So once you apply this transformation to a couple of projects, it basically learns from the feedback that you give and the agent execution, and basically it becomes smarter the next time you run the transformation. So you want something where it can take your feedback with the human in the loop and apply this to the next set of transformations. The main important thing is, since it is command line interface based, it can pretty much run from anywhere. It can run from your laptop, it can run from your EC2 instance, or a container, or in a batch mode, or even from your CI/CD pipeline. Which means you can wrap this as a batch script and say, okay, here are my 1,000 applications, go run my Java upgrade job on my 1,000 applications. So you don't have to load this in the IDE and then do it one by one. So that's the main advantage, this as a command line based interface agent. All right, how does it work, right? So let's look at what is the workflow, right? What has changed? The first thing, as always, you should have a source code that you want to transform. It could be one repository, it could be multiple repository, and again, it could be living on your GitHub repositories or GitLab or wherever, right? Wherever your source code management system is, or even your local laptop, right? Okay, and then the next thing is, you can provide additional context, right? The one thing I wanted to say here is, for AWS Transform Custom, you could do a custom transformation with your own requirements, and AWS will also provide AWS managed transformation, like for Java upgrades, for Python upgrades, for x86 upgrades, for Lambda upgrades. We actually provide the definition for you. So it's zero setup. You can get started with those conversions, right? Now, going back to the architecture here, right? So once the source code is there, you provide additional context. This is where human in the loop comes in, and you give your org-specific context. It could be a validation criteria saying that, hey, I want to use a specific command for my unit test to pass, or I want to call my smoke test suite so that after the migration is done, hey, run the smoke test to make sure it works. Or it could be other agent instruction, very specific to your company. Hey, I have a first-party library that I want to upgrade along with my Java application. I have very unique requirements on how to upgrade these Java applications, right? So those things can be given as an additional context for the agents. Now, once you provide that, basically the same thing. It will make sure it is built and tested in the source version. So for example, you're upgrading from Java 1.8 to 21 or 25, first thing, it makes sure it works in your local in the source version, right? And it could be Maven, it could be Gradle, any version of Java. Even, I mean, you could do a 1.4 Java to 25 as well, right? Okay, once that is done, then the AWS Transform Custom takes over, where again, it is a combination of multiple agents. So there is an orchestrator agent which actually orchestrates all these jobs together. First, it does a planning, right? The planning is basically, hey, how I am going to apply the transformation of Java upgrade to your current project. Basically a step-by-step instruction on what exactly needs to be done. So it creates a comprehensive plan, right? So again, after it generates a comprehensive plan, Here also, human in the loop. As a human, you can provide feedback saying that, okay, this step makes sense, this step does not make sense. Basically, it's an iterative process where at every stage you give instruction to the agent, right? Once that is done, basically execution agent takes over, where it executes that plan step by step, right? And here, the main advantage here is once the execution agent takes over, it basically creates a local branch where the command line interface is running and commits these changes, incremental changes. So you have an option to roll back to any point in time, and you can monitor what is exactly happening on these changes, right? And again, here also you can provide feedback. Okay, this doesn't really make sense. I need to change something the other way. You should be able to do that as well. Okay, so and then finally the validation and self debugger agent takes over, where it validates based on the goal that you have given. Here the goal could be, hey, I want to transform my application from Java 1.8 to 25. That could be your goal. And the validation could be my build and unit tests are successful. So it basically executes that goal, makes sure the validation criteria is addressed. And that's where, again, if there are any issues that it finds with the validation criteria, there is a self-debugger agent built in where it self-debugs and fixes the issues also for you. So it's basically this loop runs to make sure that your complete project is upgraded to your goal, right? And again, this is based on two things, right? It also refers to the knowledge base. The knowledge base is the additional context that you give, right? So for example, you can give documentation, you can give other org-specific context during additional context stage. That is actually stored as a knowledge base. So during execution, it actually refers to that knowledge base, and also, of course, it goes to large language models for the code changes. Once you get the upgraded code, right, it basically, again, the continual learning kicks in. Continual learning is basically the agent learns from the execution based on explicit user feedback. When you give feedback in the execution stage or planning stage or validation stage, it basically records all these explicit user feedback as well as the agent execution and creates what we call as a knowledge item. Knowledge item is like a memory that it creates during this execution. So where as a human in the loop, once the complete transformation is done, you can review the knowledge items created and see, hey, whether this knowledge item is applicable for my next run or not, right? If it is very generic, then you can say, hey, enable this knowledge item for my next run. So to put it shortly, the agent becomes smarter as you run this on multiple projects. So that's the workflow that we want to bring in, right, to address the challenges or the improvements that customers asked for, right? Providing their own context and supporting multiple repos, integrating with the existing system, supporting basically all these changes that we discussed about. All right. The other thing is at all these stages, right, you can integrate with MCPs, which means you can integrate with your own org-specific tools. For example, during the planning stage, if you want to refer to your documentation from your Jira or Confluence, you could do that. Again, during execution stage, if you want to refer to another repo from GitHub repo, it could do that. Validation stage, you could again call smoke test suite from another tool with this MCP integration. So at all stages, you have an option to integrate this with your existing tools and systems. All right, let's go to the demo, right? Okay, so I want to show few demos here. One, the experience of using the out-of-the-box transformation that AWS provides for just Java upgrades, right? So again, zero setup. You just see the definition and execute it, right? So this is the demo scenario. Again, from a command line interface standpoint, I'm going to list all the AWS managed transformations, and you can review what the Java transformation upgrade looks like, apply this to your current project, and you can see how it is generating a plan, how you can give the input, and validation and verification. That's the first demo that I want to show, right? This is a recorded demo, but I'll explain what is exactly going on, right? So as you see here, I have my Visual Studio Code open. I have a few Java projects that I want to upgrade, and it's a Gradle-based project in 1.8 that I want to upgrade to 21, right? And this is my terminal. I'm going to say ATX. ATX is basically the AWS Transform CLI. I'm saying, hey, list me all the definitions. Okay, so these definitions are basically stored in a registry that is applicable only for your account. So these are the AWS managed definition. Like I say, Java upgrade is one of them, which can upgrade from any Java version to any Java version. And I'm going to say, hey, ATX custom def, execute this with this configuration file. Let's review the configuration file. Configuration file contains, this is my code repository path, this is my transformation name, what build command to use, what is the validation command. I'm just saying, hey, this is my Java home, use this in my machine to build it. And also additional plan context, the natural language way of giving additional instructions. I'm going to say, hey, this is a 8 to 21 transformation, and specifically upgrade these libraries to specific version. For example, Spring Boot, go to 3.4.5. Once I execute it, it basically goes and reviews the project, basically analyzes all the project files, and creates a plan. So plan is basically how I'm going to apply this transformation on your project. Again, first do the Gradle wrapper upgrade, then do the Spring Boot upgrade, then do the deprecated API upgrades. Basically, it not only upgrades the dependencies, but also deprecated APIs, breaking code changes, all those things. Okay, and once you can review the plan, you can give additional instruction. Here I'm going to say, hey, proceed, it looks good. Now it started making these changes, right? Step one, hey, I'm going to make 1.8 to 21 changes, right? And the second, it's going to say, hey, I'm going to make these changes, right? And also there is a work log maintained that you can see what exactly is going on as well. So basically started making all these changes, right? And this is the self-debug. There is an error which it found that's not compatible, so it's making additional changes to self-debug and self-heal itself, right? Okay, so now it's complete, right? Step 2 is complete. It's going to go to step 2 or step 3, right? Now I think all the transformation steps is complete. All the systems have been upgraded, and it basically lists down all these things which have been done, right? So what exactly it has upgraded? Gradle wrapper, Spring Boot, all the libraries, what code changes, what is the final status. Currently, the validation criteria is successful for this application, right? So this is how you do the, use the out-of-the-box transformation which is being provided by AWS to transform your application. What you see is an interactive mode, right? Meaning, hey, I was able to interact with this and then do it. But you can also do it in a batch mode, which I will show in a couple of moments. Okay, so let's go to a next demo, right? So first we saw, hey, how you can upgrade it. The second thing, how you can create your custom transformation for your specific scenario and then execute it, right? So this is where it gets interesting, where, hey, you basically give your requirements to create the definition for your use case, and you can execute it, right? Again, since this is Java upgrade session, I'm showing Java, but this actually supports all the languages. You could do Python, you could do .NET, you could do Rust, all those things as well, right? So the second scenario I'm going to show is how do you create a new custom transformation definition, review it, provide it, and again, publish to the registry. Registry is basically, once you create a definition, you can publish to your own account, so other users can use the same transformation definition for their projects with similar use cases, right? And so apply this plan generation and validation. Here, the specific scenario that I took is, I've upgraded my current application from 1.8 to 21. Now I want to modernize it, refactor it with newer performance improvements of Java 21. That's the thing that I'm going to show, right? And also I have a Docker container, so how to upgrade the Docker files with the newer images as well. All right, again, same thing. I'm going to do this in an interactive mode, which means that I'm going to converse with the converse with a CLI to make this thing happen. Okay, I open this interactive mode. I'm just saying, hey, create a new one for me. This is a new transformation. All right, now it is going to ask what exactly you want to do. I'm saying, hey, modernize my 21 project with the Java 21 features and also update the Docker file. Cool. Now it is going to search for if there are already existing transformation. I'm going to here say, hey, go ahead and create a new one here for me. Okay. So now it's going to again ask me, hey, are there any specific documentation, any specific context that you want to give, right? I'm saying, hey, use the best practices for Java 21 modernization or refactor, go create this, right? So this is before the planning stage where it actually creates the definition itself. Okay, so now it created a definition. Definition has a clear objective, a summary, an entry criteria, basically taking only the Java 21 project as an input and going for modernization, and a step-by-step instruction what exactly needs to be done. For example, hey, convert my POJOs into records, right? Implement pattern matching. So these are all newer features introduced in Java 21 that it wants to use, right? Virtual threads. And Docker file updates. So basically whatever, based on your requirements, it's actually creating you the definition or the recipe that you can apply for multiple projects. Okay, so, and what is the validation criteria? How do you want to validate? So here also you can provide input, hey, my build and unit tests are successful, which means the goal is achieved, right? Okay, so now it's created the definition. Again, you can modify it or publish it so other users can use it, or apply it to your current project. Okay, so now I'm going to publish this so that I feel comfortable with my recipe here. Hey, go publish it so other users can use it. Okay. Okay, so it's basically published to your registry, which is specific to your customer account, right? All right, so it published now. Now I can use this and apply to my projects. So I'm going to say one, which is applying to my project. Again, it's going to ask me, hey, where is your project? What's the build command to use, right? Again, the same thing happens. So now it is going to create a plan. You can review the plan, validate it, and then go from there. So let's see what exactly it's doing, right? So it created a plan here, right? So again, it says that, okay, this is a multi-module Gradle project. This is the entry criteria, and project is already on 21. So the plan includes 10 steps. First, I do the record conversion, then text block modernization, then pattern matching. So it's basically whatever requirements I've given, right? Docker modernization and legacy modernization as well, right? Okay. And it also says if the project does not contain few steps, which is not applicable from the definition itself, it notes that, okay, this is not applicable for this project, right? Now again, here also you can give feedback. I'm going to say, hey, looks good, proceed. Awesome. Now it's going to make the changes, right? Okay, the first change is it's going to make configuration key into a Java 21 record. All right, this is the old string and new string. It's basically replacing the newer version. Okay, so now it's complete. All the things are successful, right? Transformation is complete, and it gives you a summary of what exactly has been done. Again, as I told, it creates a local branch where you can compare and see what's going on, but it also provides you a summary. Okay. Okay, once the changes are complete, it again does a validation to ensure that all the changes are being done. So making sure that the exit criteria is met. Okay. So here the build is successful, and this modernization was successful. All right. Okay, there's no issues found with this modernization, and you should be able to compare with the git diff on what exactly changes have been done and see and push the changes as well, right? Okay, so what we saw is creating a definition from scratch for your requirements, applying it on your project, reviewing it, and making sure it happens, right? All right. The third thing, right? The most important thing is how do you scale? Okay, this is great. You have created a transformation, you have applied on one project, very similar to what we have. Now, how am I going to apply this for 1,000 projects, right? What is the thing, right? Since this is a CLI command line interface, you can basically wrap this up in a bash script. It's all it needs. It's a shell. It works on a Linux environment. It works on Mac. It works on Windows through WSL. So as long as you have a batch script that can, basically run it across your repository, you can run it, right? It could be a batch script, or you could just put it in a container and run it, or AWS batch, or any scaling mechanism that can be done, right? Okay, so let's see how that works, right? So I have a batch script here, right, which I created called ATX Batch Launcher. It's basically it's a wrapper around this ATX CLI, saying that okay, it executes ATX CLI in parallel or in serial, taking a CSV file as an input, right? It takes a CSV file as an input, and what mode, hey, parallel or serial mode, and whether you want to trust all tools so it can execute without human in the loop, and what is the build command to use, what are the additional parameters to use, right? Okay, so now let's take a look at the repos, right? So this is the repos that I have. I just gave a bunch of GitHub repos, which is in 1.8, and I say, hey, this is my Gradle projects. Go run my out-of-the-box transformation provided by AWS. This is my Java home, and use this as a 1.8 to 21 migration, right? Okay. And those are the two inputs I give, and I am just launching again the script, saying that, hey, launch this script with this CSV file as an input, have parallel mode, 10 jobs maximum. The cloned directory is this local directory in my machine, right? I'm just going to execute this. Okay, it basically spawns 10 threads for the ATX CLI and does this job, right? And you could do this not only from your machine, as I told, just put it on an EC2 container or EC2 or containers and run it as well. Okay, so basically you can monitor the progress as well, what exactly is happening. So just opening this, it basically opens up a CLI, what I did, like a ATX CLI in an interactive mode, but does it in a non-interactive mode, which means that I trusted all tools. I'm running it in non-interactive, so don't ask me for any question, go execute it. It also created a config.yaml for each and every transformation that you can review it as well. Okay, so now it is complete. So it had one failed repositories, but all the others are successful. The one failed was basically because there was some repository preparation was failed, but that's due to my credentials. But I just wanted to show, hey, how easy is to scale this across your projects, right? Again, for Java, like I showed in the first demo, if it's plain vanilla Java upgrades, just use the out-of-the-box thing that we already gave you. Just run with that, right? Unless you have unique requirements that you want to do, just run with the out-of-the-box transformation. Cool. Okay, so yeah, so the status is passed for most of the transformations. Okay, so the next one I want to show is continual learning aspect, right? So now we started with the out-of-the-box transformation, then we graduated into creating our own transformation. Now we saw how you can scale it. Now how the continual learning works. How does the agent become smarter the next time, right? So I'm going to use the same demo scenario, like the same Java 21 modernization custom thing that I created and ran across the projects, and capture these knowledge items and list it, review it, and enable it. Okay. Okay. So again, just as an example, this is what I ran, like ATX custom def exec for multiple projects. Okay. Okay. So now assume that all these transformations are done, right? Now I can go back to another terminal and list these knowledge items that are created. Let's see how that happens. Okay, so I'm going to say ATX custom def list knowledge items for this transformation, right? So it's listing all the knowledge items which it found from the explicit user feedback as well as agent execution. So some of them it found was, hey, Gradle Shadow plugin outputs into this path. SolarWinds and Morpheus, this is very specific to that project. So maybe not applicable to enable for other projects, right? Groovy text blocks required 2 strings. So it captured specific things it found from the agent execution that can be applicable for other projects as well, right? Seal classes fundamentally are incompatible with JPA Hibernate, right? Record conversion requires systematic getter method migration. So these are some things that it learned, right? Okay, so now what I'm going to do is I'm going to pick up some generic items and I'm going to enable this, which means that next time I run, it's already enabled, and then that will be automatically taken care. Okay, I'm going to say, hey, this knowledge item, go and enable it, right? Same thing with a couple of other knowledge items as well. I'm just going to enable a few of the knowledge items. So when you use the same account, same transformation name, it's basically going to make sure that this is already taken care. It doesn't have to do this again and again. This is especially important where you have multiple teams working and they capture knowledge items. So you centrally have all these memory or organization specific knowledge items that you can enable it and track it, right? So how we envision this to be working is a central team creates these kind of transformation who are the domain experts, and then distributes this to the application teams so they can run it and make sure that it works and then apply at scale. So that's the process that we envision. But each company is unique, right? You might not have a centralized team where developers are decentralized. That is also possible, where you can run this within your teams, within the account, so those knowledge items are captured. All right, those are the things I want to cover with the demo, right? Ben, want to wrap it up?
Thank you, Vinay. As we start to wrap this up, a few key principles to highlight from AWS Transform Custom. First is the continual learning capability that Vinu just highlighted, where the transformation definition can be improved over time, either through agent-generated critique or through developer-generated critique. Second is the guided transformation definition creation. When you're first creating a definition, Vinu highlighted the ability for intelligent feedback loops to identify missing context and to prompt the user for extra instructions in the case of ambiguity. We have the concept of learn once, transform everywhere. So your developers should not be spending duplicative time creating transformation definitions that are common to your organization. You can create it once, you can vet it once, and then publish it to your internal registry. And lastly, we have the concept of organization-wide transformation campaigns. So from a central PMO office or developer office, you can manage these transformations at scale. Now, as we wrap up, let's go back to our quest against the modernization monsters. The documentation dragon. So you can see from AWS Transformation Custom how a transformation definition can automatically create updated documentation for your project or net new documentation based on the instructions that you give it. The testing troll. A transformation definition will update existing tests or again create net new tests for your project. Module monster. We support multi-module projects out of the box. And for the version vampire, the CLI tool has all the functionalities to address breaking changes. Lastly, the dependency dinosaur. So we support all common third-party dependencies and frameworks like Spring Boot, Hibernate, Apache libraries, etc. And these culminate in, again, the time-sucking tarantula. VJ highlighted 60% faster transformations at ADP, and we've seen customers achieve up to 5x acceleration in their transformations. As far as next steps, this tool is available for you today. Maybe to get started, an easy way is to try updating documentation or creating new documentation for an existing project. You could then move on to maybe using one of our out-of-the-box transformation definitions, such as our Java transformation definition. And then you can go on to expand to your larger projects or create your own definitions. You can find more resources on this at Skills Builder for AWS transformation, as well as all of our other AWS services and the announcements from this week. So I'd like to thank you all for coming today. Invite you to please complete the session feedback in the mobile app. We won't take Q&A right now, but we'll be happy to take it afterwards beside the stage. And with that, thank you all for coming.
Thank you.
Thank you.